A large container shown in the cross section is filled with a liquid of density 1.1 times 10 to the power of 3 kilogram per cubic meter. A small hole of area 2.5 times 10 to the power of negative 6 square meters is opened in the side of the container a distance h below the liquid surface, which allows a stream of liquid to flow through the hole and into a beaker placed to the right of the container. At the same time, liquid is also added to the container at an appropriate rate so that H remains constant. The amount of liquid collected in the beaker in 2 minutes is 7.2 times 10 to the power of negative 4 cubic meters. Calculate the volume rate of flow of liquid from the hole in cubic meters per second. Calculate the speed of the liquid as it exits from the hole. Calculate the height h of liquid needed above the hole to cause the speed you determined in part B. Suppose that there is now less liquid in the container so that the height h is reduced to h by 2 in relation to the collection beaker. Where will the liquid hit the tabletop? Left of the beaker, in the beaker, right of the beaker. Justify your answer. This numerical is based on equation of continuity and volume flow rate. The density of the liquid is given, rho is equal to 1.1 times 10 to the power of 3 kilogram per cubic meter. And then area of cross section is given to us 2.5 times 10 to the power of negative 6 square meters. And we know volume flow rate Q is equal to delta V over delta T is equal to A V. Okay, here we have to find out Q and then we have to find out V. Okay, so delta V by delta T is given to us. Delta V is equal to 7.2 times 10 to the power of negative 4 cubic meters. And then delta T is equal to 2 minutes. That means 120 seconds. Okay. Therefore, Q is equal to 7.2 times 10 to the power of negative 4 divided by 120 seconds. So this is cubic meters. So this is equal to 6 times 10 to the power of negative 6 cubic meters per second. Now, Q is equal to AV. Q is known to us, and then A is given in the question itself. We have to find out V. Therefore, 6 times 10 to the power of negative 6 is equal to 2.5 times 10 to the power of negative 6 square meters times V. Therefore, V is equal to 6 times 10 to the power of negative 6 divided by 2.5 times 10 to the power of negative 6 is equal to 2.4 meters per second. So we found out A bit and then B bit. Now we have to calculate H. To find out the H, we use the Bernoulli's principle. What is Bernoulli's principle? P1 plus rho G H1 plus half rho V1 square is equal to P2 plus rho G H2 plus half rho V2 square. Now here what we do is P1 is equal to P2 is equal to P, that means atmospheric pressure. Am I right? Because both the containers are open. Therefore, the pressure acting on them is the atmospheric pressure. This one and this one. Open containers. No? That's one. Therefore, P1 goes off, P1 and P2 goes off. And then I am making H2 is equal to 0, reference point 0. Okay, and then I will consider V1 is much less than V2. That implies V1 is negligible. Therefore, V1 goes on, V1 becomes 0, implies V1 is equal to 0. Okay, therefore, what is left here? This point, this goes off. Am I right? And then P2 goes off. And then V1, because V1 is equal to 0, this factor also goes off. And I am left with only 2. Rho G H1 is equal to half rho V2 square. Am I right? So rho cancels out. And then H1 is equal to V2 square divided by 2G. Am I right? So this is equal to 2.4 times 2.4 square divided by 2 into 9.8. So the answer is 0.29 meters. Okay, that's it. And then the last one, D bit. Here, I give you there are two ways to solve this problem. One is pressure is equal to H rho G. That means as the H decreases, P decreases. Okay, as P decreases, delta X decreases. Okay, that means the distance from the hole becomes less. Okay, so it falls left of the beaker. This is one way to solve the equation and solve the problem. Another way is from this equation, half V2 square is equal to GH. Am I right? That means V2 square is equal to 2GH. And this implies V2 decreases as H decreases. Here H is decreased to H by 2. Am I right? Therefore, V decreases. What happens if V decreases? We know displacement is equal to velocity times t. Am I right? Just a moment. Velocity times t. Here, the velocity decreasing. So, as the velocity decreases, delta x decreases. Am I right? So, as V decreases, delta x decreases. So, it falls before the uh, small container. That means to the left of the beaker. This is the beaker. So, left of the beaker, it falls. In either way, you can answer this question. Hope this helps. Thank you. Bye bye.